Team TechGyros, here to present our working of the software PATRION, a smart adaptive traffic light management system. This is our solution proposed to the problem statement ID 1607. First, let us go through the tech stack. Ultralytics model from YOLO V5, a pre-trained machine learning model for computer vision. It is used to detect and track vehicles. DeepQ network. DeepQ is an algorithm that analyzes the given data and predicts the optimal green light timing for a traffic model. Hidden Markov model (HMM) is an algorithm that is used to quantize the traffic level and predict future traffic. Finally, we use Python for implementing the mentioned algorithms. The required hardware are Ethernet switch and cables for connecting traffic light modules, a storage unit for temporary data storage, pre-installed cameras at traffic junction to get our visual inputs. For the admin interface, we use HTML, CSS, JavaScript and MySQL. Now let's dive into the workflow architecture. We have divided our workflow into 4 phases. Phase 1, vehicle detection and tracking. It is done using YOLO V5. Phase 2, implementation of DQN for dynamic allocation of green light timing. Phase 3, implementation of IPC, inter-process communication and hidden Markov model. In IPC, we specifically use state transition, runoff and signal off method for traffic light switching. Phase 4, implementation of admin interface and dynamic switching control. From the camera, the visual input is analyzed using the YOLO V5 and we extract 3 features from it. First, we augment a virtual range line. Then we calculate the distance between the line and the recently passed vehicle. We do this to measure how filled the tracking area is. Second, we calculate the number of vehicles in the current frame. Third, a temporary log is maintained of the video footage and the number of vehicles passed per time interval. This data is given to HMM to predict the number of vehicles that will pass per time interval. Now, all the 3 above mentioned data is given to DQN by analyzing the input data. The DQN gives dynamic green light timing. This data is then fed into the traffic light module. In phase 3, we have an intersection or traffic junction with 4 traffic light poles, each with a module consisting of the code that implements DQN, HMM and IPC. The IPC is used to communicate among the traffic light modules, telling which one must switch to next green. The runoff method indicates that the green light timing is running in the traffic light module. The signal off method tells the next traffic module to switch green light. When one traffic module is in runoff state, the rest of all must be in red. If traffic module A is in green, then the traffic module B must switch to green next, then C, then D, then A and so on. For each traffic module, the green light timing is assigned dynamically by DQN. The HMM present on each module will analyze the traffic and quantize the congestion level. This data is sent to the DQN present at the next adjacent traffic module in another junction along the same trajectory. Now the DQN will have 4 inputs, 3 from the phase 1 and congestion data from the phase 3. By analyzing all the input data, it dynamically assigns optimized green light timing for the traffic module. This prevents congestion that will occur by distributing the traffic. At every junction for an area, there is a traffic control room present, from where the traffic light and cameras are monitored. Our interface lets the traffic control officer to visualize real-time tracking of vehicle and has an option to remotely enable and disable the smart dynamic traffic management system, PATRION. For emergency management like path clearance for emergency ambulance, we propose a solution based on IoT, where the ambulance will have a radio signal transmitter and the traffic module will have a receiver. When the traffic module receives a signal from the particular frequency, it goes green until the signal is not detected. This works just like a TV that keeps on increasing the volume when the volume button in the remote controller is being pressed. That's our complete working model architecture. Please watch the other videos in the playlist to visualize it better. Thank you.